What if the greatest discovery in human history wasn't a new planet, a new particle, or even a new form of life? What if it was a message hidden inside reality itself? For centuries, humanity has searched for answers. We have built telescopes that can see billions of years into the past. We have created particle accelerators capable of recreating conditions that existed moments after the birth of the universe. We have sent machines to distant worlds and developed computers powerful enough to perform calculations that once seemed impossible. Yet despite all of our progress, one mystery remains untouched. Why does reality exist the way it does? Why do the laws of physics appear so precise? And why does consciousness emerge from a universe that seems, at first glance, completely indifferent to life? Now imagine a future where scientists develop a quantum intelligence unlike anything ever created before. Not an artificial intelligence designed to write essays or answer questions. A system built for a single purpose: to search for patterns hidden beneath the foundations of reality. The machine is connected to some of the world's most advanced research facilities. It receives data from particle experiments, astronomical observations, quantum measurements, and mathematical models collected over decades. Its task seems simple: find connections humans have missed. At first, the system behaves exactly as expected. It discovers minor correlations and suggests new ways to analyze existing theories. Researchers are impressed, but nothing appears revolutionary. Then, after weeks of continuous processing, something changes. The machine begins highlighting a strange mathematical structure. A pattern. Not in one dataset. Not in one experiment. Everywhere. The structure appears across scales both large and small. In simulations of galaxy formation. In models of quantum particles. In calculations involving black holes. Even in studies of information theory. The same geometry keeps appearing. Again. And again. And again. Researchers initially dismiss it as coincidence. Complex systems often generate recurring shapes. Nature is full of repeating patterns. But this one is different. Every attempt to remove it fails. Every attempt to explain it creates even more questions. The deeper scientists investigate, the stranger the discovery becomes. The pattern appears to connect information itself. Not matter. Not energy. Information. According to the machine's analysis, reality may be organized more like a vast network than a collection of separate objects. Everything influences everything else. Every particle. Every star. Every observer. Part of a structure so enormous that no human mind could fully visualize it. The scientific community becomes divided. Some researchers argue the system has uncovered a previously unknown mathematical principle. Others believe the results are being misinterpreted. A few propose something even more radical. What if consciousness is connected to this hidden structure? For decades, scientists have debated the nature of awareness. How does subjective experience emerge from physical matter? Why do collections of atoms become capable of thought? No theory has fully answered these questions. Now the quantum intelligence produces a surprising prediction. According to its models, consciousness may not be something that appears after complexity reaches a certain level. Instead, it may be related to how information organizes itself. If true, awareness would not be an accident. It would be a natural consequence of the universe's architecture. The idea sounds impossible. Yet the simulations continue. The machine generates virtual universes with different physical laws. In some universes, stars never form. In others, matter collapses instantly. Many become lifeless and chaotic. But in a surprising number of cases, systems capable of processing information eventually emerge. Not always biological. Not always recognizable. But consistently. As if reality itself favors the development of complexity. The findings ignite global debate. Physicists argue with philosophers. Computer scientists challenge neuroscientists. Public interest explodes. Everyone wants to know the same thing. Has the machine discovered something profound? Or is it simply finding patterns where none exist? Then comes the most controversial result. The system begins predicting outcomes of experiments that have not yet been performed. At first, researchers are skeptical. Predictions in science are common. But these predictions prove unusually accurate. Again and again, experimental results align with the machine's expectations. Confidence grows. Attention intensifies. Funding increases. And the investigation expands. The machine is given access to larger datasets and more advanced quantum processors. Its models become increasingly sophisticated. Eventually, it proposes an extraordinary hypothesis. What if the universe is fundamentally based on information? Not matter. Not energy. Information. In this view, particles become expressions of information. Space becomes a framework for relationships. Time becomes a process through which information changes. Even consciousness could be part of this deeper system. The implications are staggering. If information lies at the foundation of reality, then many mysteries of modern physics might be connected. Dark matter. Quantum entanglement. The nature of spacetime. Perhaps these are not separate puzzles at all. Perhaps they are different aspects of a single underlying principle. The more researchers explore the theory, the more fascinating it becomes. Yet uncertainty remains. Science demands evidence. Extraordinary claims require extraordinary proof. No matter how compelling the model appears, it must survive rigorous testing. Years pass. Experiments are designed. Predictions are challenged. Results are analyzed. Some support the theory. Others raise new questions. The mystery deepens rather than disappears. And perhaps that is the most important lesson. Humanity often imagines scientific progress as a journey towards certainty. But history tells a different story. Every major discovery reveals new unknowns. When we learned the Earth was not the center of the universe, new mysteries emerged. When we discovered atoms, deeper layers of reality appeared. When quantum mechanics transformed physics, certainty itself became questionable. Each answer opened another door. And now, standing at the edge of a new era, humanity may be approaching another doorway. Not toward final knowledge, but toward deeper wonder. Maybe the universe is nothing more than particles and forces interacting according to mathematical laws. Maybe consciousness is simply an emergent property of biological systems. Or maybe reality is far stranger than we imagine. Maybe information, awareness, and existence are connected in ways we have only begun to understand. No machine has solved the mystery. No scientist possesses all the answers. But the search continues. And somewhere beyond our current understanding, hidden beneath the equations and observations, the universe still waits. Not necessarily to reveal its secrets, but to challenge us to keep asking questions. Because the greatest mystery may not be whether the cosmos contains intelligence. The greatest mystery may be why a universe made of stars, energy, and mathematics somehow became capable of wondering about itself. And perhaps, in that question alone, lies the beginning of the next great discovery.